Question 1 asks you the unit for a reaction rate. The reaction rate always concentration change over time, right? Any reaction rate always concentration change with time. And concentration change, the unit is the same as concentration. This is more per liter. This is more per liter. And the time is second, right? So the unit will be more per liter per second. Then you choose D. D asks you what is the unit for the reaction rate of a first order reaction. The unit for the rate constant of first order reaction. The rate law for first order reaction equals to K times reactant A's concentration raised to first power. Right? K is a rate constant. A in a bracket means concentration raised to first power. One way omit. Since the rate unit is more per liter per second, right? Then K, we want to figure out K, rate constant. And concentration is more per liter. Concentration is molarity, is more per liter, right? Then you find more per liter exactly the same, both sides. So clearly, the K will have unit per second. Right. This is for first order reaction. Okay. So you choose A. Rate constant for first order reaction unit is per second. Yeah, we talk about this during the class. Okay. For second order reaction will be different. You just use the similar way. So second order reaction, this time you need to put second order here. The rate unit is the same. K you want to figure out. Then this second power, there's a more square per liter square. Right. Then figure out what is the K unit. Then should be the per mole liter per second, second order. First order is the simplest. And question 3, for the reaction nitrogen react with hydrogen produce ammonia. That's a gas reaction. All reactants and products are gas. Tell you if the rate of nitrogen consumption or disappearance is 0.25. The rate of nitrogen is 0.25. Molarity, this capital M is the concentration, is the molarity, mole per liter per second. Ask you, what is the rate of ammonium formation? Okay, you need to take a look at the balance equation. For every one nitrogen disappear or consumed, will produce 2 more ammonium. So nitrogen 0.25, then ammonia will be 2 times 0.25. All right, should be 2 times 0.25. Because the balance of the equation tells you this relationship. Every one nitrogen disappeared or consumed, while 2 ammonia formed. So if nitrogen rate is 0.25, the ammonium rate will be 2 times 0.25, which is 0.5. Okay, so you should choose B, 0.5. Are you okay with this? Because this balance equation tells you ammonia formation rate is 2 times faster compared to nitrogen. Okay. Then question 4. Ask you what is the overall order for the reaction to which rate law is Q times NO concentration times Cl2 concentration. What is the overall reaction order?
I think you had that. I think you're on the wrong thing.
Huh? Wrong thing?
It should be O2, not CO. For number 4.
Oh, yes. I read the wrong thing. Yeah, the NO2. Yeah, question 4. Yeah, I read the question 6. This also NO is 2. O is no number means 1. Then what is the overall reaction order? 2. No number means 1. Total should be 3. Okay, then you choose C. C is 3 reaction order. Are you okay with this? This is a very simple question. Okay, don't just neglect this. No number means 1. Okay. Then question 5. The half-life of a first order reaction is 50 seconds. At 70 degrees Celsius. Ask you what is the rate constant of the reaction. Tell you half-life of a first order reaction. Ask you rate constant. So you need the relationship between half-life and the rate constant. Right? Do you remember that formula? Right. Natural log 2 is 0.693. Right. So half-life is non-value. We can just switch this, calculate K. So K will be 0.693 over half-life. So you get 1.39 times 10 to the second power, negative second. Unit is per second, second in denominator. So you should choose choice D. Question 6. Here is the rate law of this reaction. 2NO react with Cl2 produce 2NOCl. The rate is given by this equation. K times NO concentration and Cl2 concentration. And the mechanism of this reaction involves 2 steps. Propose the mechanism. Step 1, NO react with Cl2. 1 NO react with 1 Cl2 produce NOCl2. Step 2, NOCl2 further react with another NO, produce 2 NOCl. Ask you, which step is the rate determining step? Remember, a student asked me a similar question before the quiz, right? Similar question. So, which step is a rate determining step? It's which step give you same rate law? That is rate determining step. The proposed mechanism, step 1, step 2. So mechanism, each step is a elementary reaction. For any elementary reaction, we can easily write the rate law. Okay, this is for elementary reaction, we can easily write the rate law just based on this equation, but not for this overall reaction. This equation, you cannot write the rate law from this overall reaction equation. Okay, but each step is an elementary reaction. Then we can easily use this equation to write the rate law. So what is the rate for this step? K is rate constant times reactant, both coefficient is 1, right? So this should be K times NO and Cl2. What is the rate for step 2? K10. Again, this both are 1, right? So both warm up. Then just concentration. Both 1, right? Then which of these same as overall rate law? Clearly step 1, right? Step 1 give the same rate law as the overall reaction. So step 1 gives the same rate law as that of the overall reaction. So step 1 is the rate determining step. Okay. Are you okay with this? Okay. The next 2, most problem come from next 2. You must show work. Okay. Question 7. first order reaction on a one reactant, shifted the self, converted to product. The first order reaction. And tell you the rate constant is 1.50 times 10 to the negative 2 power per second. Ask you how long would it take for concentration of reactant A decrease from 1 to 0.05. Concentration A decrease from 1 to 0.05. Ask you how long it takes. Reactant concentration decrease from 1 to 0.05. How long it takes? Then you need to use integrated rate law. Of course, for first order reaction, integrated rate law for first order reaction is natural log of A over A0. A is a concentration at the time T. A0 is the initial concentration equal to negative K times T. Right? Concentration at the time T, initial concentration, right? Concentration of time at time T, right? Initial concentration. These two are known value, and K is a known value. Can you solve for T? Yeah. For solve for T should equal to negative natural log of A over A0 divided by K. Right? Now just plug in the number. Negative natural log of A, final concentration, 0.05. A0, initial concentration is 1. K, 1.5 times 10 to the negative 2 power per second. Right, per second in denominator, whatever is second. This is the unit we want. Right. Use your calculator. Okay. 0.05 divided by 1, 0.05. Okay. Then use your calculator, log of 0.05, then divided by 1.5 times 10 to the negative 2 power. This gives you 199.7. If you report as 200, it's fine. This is actually not very complicated. The only thing is you need to remember this integrated rate law. You need to remember this integrated rate law. Tell you relationship between reactant and the time. Are you okay with this now? Okay. Then question 8, also a big problem for some of you. Okay. The reaction is CO gas. Reactor is Cl2 gas. Produce COCl2 gas. Material rate at 150 degrees Celsius is 500 times faster than that at 90 degrees Celsius. Of course, under same temperature, under same concentration. Also, you calculate activation energy, EA. Rate at 150 degrees Celsius is 500 times faster than that at 90 degrees Celsius under same concentration. So we know any rate law looks like this, right? Of course, this reaction order will be different for different reaction, right? But looks like this, raised to X or raised to Y. But since here under same concentration, if reactant concentration same, then at two temperature, these two, the concentration part is same, right? The rate only depends on this rate constant because we point out is under same concentration, then rate only depends on rate constant. This means rate constant at 150 degrees Celsius will be 500 times as a rate constant at 90 degrees Celsius. Okay, so rate, so K2 is a rate constant at 150, which is T2, right? The K2 you use T2. Okay. And K1 is a rate constant at 90 degrees Celsius. We design this as T1, right? You need to decide which one is T1, which one is T2, and then K1, K2 you need link with them. 当的swap. Okay, can you understand this statement? The rate at 150 degrees Celsius is 500 times faster as that at 90 degrees Celsius. Under same concentration as C, and the rate law looks like this. Of course, this is X, this is Y. Could be not 1. It could be X and Y and a number. But since the concentration are same, then you don't need to care about this part. So rate only depends on this K. So this means this statement tell you K2 equal to 500 times greater than K1, where K2 is at 150 degrees Celsius. It's T2. K2 linked with T2. Then K1 will be at 90 degrees Celsius. So 90 degrees will be 1. Of course, you need to convert it to Kelvin. You cannot use Celsius directly. Then the equation is natural log of K2 over K1 equal to EA, not EA1, EA. Okay. Equal to EA divided by R times reciprocal T1 minus reciprocal of T2. Okay. If you give this equation, you made 2 points. Okay. Just give this equation. Second step, plug in the number. Another 2 points. Okay. According to this, plug in the number. K2 equal to 500 times faster than K1. So 500 K1 over K1. So this side is a pure number, right? K1 can be cancelled. Then EA. R is a gas constant. I'll provide you this number there. 8.314 joule per mole per K. Okay, be careful the order. K2 over K1. This side is T1 first, T2 next. So T1 is 90 degrees Celsius. Again, you cannot use 90 directly because it's Celsius. We need to convert the Celsius into Kelvin. 90 plus 273. More accurately is 273.15. If you use 273, it's fine. Okay. Then T2 150 also converted to Kelvin. So this both are Kelvin, right? So Kelvin cancel this per Kelvin, left over joule per mole. Then you solve this equation. EA unit also joule per mole. Solve this equation. Your answer will be EA equal to 13 to 23, 28 joule per mole. How to solve this equation? This is pure math. Okay? First of all, cancel this K1 becomes a pure number. Log of 500. You get this. Use your calculator. Okay? Then both sides multiply by 8.314. Right? You get another number. Then both sides divided by this whole thing in the parentheses. Of course, you need to figure out this first. Then both sides divided by this. It's pure math. So we don't have time to show you step by step for the pure math. As I said, as long as you give this formula equation, you made 2 points. If you plug in the correct number for this equation, you made another 2 points. Final answer only 1. This gradient polynomial is similar in the test. Okay, equation plug into correct number. That's more important than the final answer. Do you have any other